For number 13, we're asked to find the absolute max and the absolute min, and this time we're given a bounded region. So we have to look from -4 to an x value of +3. So we're bounded by these x values. So we're going to find out where the first derivative equals 0. And let's write our function a little differently before we start. We're going to write this as x minus 4. We're going to bring up this x squared, we're going to bring it up to the top, and it's going to become x to the -2 power. And let's take the derivative then of that. So that would be 1 plus 8, and then x to the -3 power. And then let's write this with only positive exponents. All right, we're looking for where the first derivative equals 0, or where the first derivative is undefined. And the first derivative equaling 0, let's bring this over to the other side, so that's 1 equals -8 over x cubed. Let's solve this by cross multiplying, so I'm going to put this over 1. So that gives me -8 is equal to x cubed. We're going to take the cube root of both sides. The cube root of -8 is -2, and of course the cube root of x cubed is x. Now remember that we're looking for relative maxes and relative mins, and then we're going to compare them and see which one actually represents the absolute max and absolute min. We're looking for where the first derivative is undefined. The first derivative is undefined at x equals 0. But could this be a potential relative max or a relative min? If we go back to the original function, what happens if we plug a 0 in place of x? If we plug a 0 in place of x, we get 0 squared in the denominator and it comes back undefined. So we want to keep in mind that we are looking for relative maxes and relative mins to compare to see which one is actually absolute max and absolute min. And relative maxes and relative mins have to be points on the graph. 0 is not a point on the graph, so I'm not going to bother writing it down to compare it to the other values. So we're going to check out -2 into the original function. We're also going to check the endpoints. So we're going to put in -4 and also +3. So if we put a -2 into the function, I'm going to go ahead and write out my function. If we put a -2 in, we get, let's put down here, we get -2 minus 4 divided by a +4, which is -2 minus 1, which gives us -3. So we're going to compare that to what do we get when we put a -4 into the function. Okay, so that would be equal to -4 minus 4 divided by a +16. And that's -4 minus 1/4, which gives us -4 and 1/4. And as a decimal, of course, this will be -4.25. Okay, and we're going to compare that value to what happens when 3 goes into the function. Okay, in this case, we would end up with 3 minus 4/9. Let's go ahead and give them the same denominator. Multiply top and the bottom actually by 9, since the common denominator would be 9. So that gives us 27 over 9 minus 4 over 9, which gives us 23 divided by 9. And let's look at the decimal value of that. That would be 2.56 approximately, so that would be the approximate decimal value for that one. Alright, so remember that we're looking for the absolute max and the absolute minimum. Remember, since we have a bounded region, that we're going to be able to find both. So the absolute max of the function f on this interval, and of course it's important that we're talking about on this interval. So the absolute max here, well, the only positive value that we have was 2.56. That's the 23 over 9. So the absolute maximum value would be 23 over 9, and it occurs at the point 3, 23 over 9. And the absolute minimum value of f, so let's look at the other two values are negative. We're going to look for the most negative value. So that would be negative 4 and 1/4. And it occurs at negative 4, comma, negative 4 and 1/4. So we are able to find an absolute max and an absolute minimum value for this particular given interval.